Hi friends, welcome to Think Maths. So in this session, we are going to discuss about examples 2, 3 and 4 from the chapter 2 polynomials. Another topic zeros and coefficients. So here we have to prove the relationship between the zeros and coefficients. So the given polynomial is x square plus 7x plus 10. Okay. So let us take p of x equal to x square plus 7x plus 10. So here we have to find two terms such that the two terms satisfied. The sum should be equal to 7 and their product should be 10x square. Okay. So if these two conditions are satisfied, then we can partition. Okay. So sum of two terms should be equal to 7x. Okay. And the product of two terms should be 10x square. So we have to find the two terms. So the two terms will be 5x and 2x. Okay, so 5x into 2x will be 10x square and 5x plus 2x is 7x. So we can split this polynomial. So x square. So instead of 7x, we can write 5x plus 2x plus 10. Okay, so in the first two terms, we can take x outside. So the remaining will be x plus 5. In the next two terms, we can take 2 outside. So the remaining will be x plus 5. So here x plus 5 is common. So we can take x plus 5 outside. So if I take x plus 5 outside, the remaining will be here x in the second term plus 2. So x plus 5 into x plus 2. So this p of x will be equal to 0 when x plus 5 is equal to 0 and x plus 2 is equal to 0. So when x plus 5 is equal to 0 and x plus 2 is equal to 0. So then we get x is equal to minus 5. Okay. So when x plus 5 is equal to 0, we get when x is equal to minus 5 or when x is equal to minus 2. So x plus 2 is equal to 0 means this plus 2 will become minus 2 in RHS. So x is equal to minus 2. So these are the zeros for the quadratic polynomial. Now we have to find the relationship between the zeros and coefficients. So sum of the zeros and we have to find the product of the zeros and show this term is equivalent. So what is sum? Sum is minus 5 plus minus 2. Okay. So this is equal to minus 7. So this can be written as minus 7 divided by 1. Here 7 is nothing but coefficient of x. So which is equal to one negative term is here minus coefficient of x divided by 1 is the coefficient of x square. So we proved that sum of the zeros equal to minus coefficient of x by coefficient of x square. Product of zeros. So minus 5 into minus 2. Okay. So minus into minus is plus. So the answer will be 10. Okay. So 10 we can write as 10 divided by 1. So 10 is nothing but a constant term and 1 is nothing but coefficient of x square. So product of zeros is equal to constant term divided by coefficient of x square. So we found the zeros and we verified the relationship between zeros and coefficients. Okay, can you understand? Okay, children. So let me go to the next problem. Example 3. Find the zeros of the quadratic polynomial x square minus 3 and verify the relationship between the zeros and the coefficients. So this is same as example 2. Now let us solve. Let us take p of x equal to x square minus 3. So we know that a square minus b square is nothing but a plus b into a minus b. So we have to write this equation in this form. So x square minus, here 3 can be written as root 3 whole square. Okay. So this is of the form a square minus b square. So we can write a plus b, that is x plus root 3 into a minus b. So a minus b means x minus root 3. Okay. So what happens? Then p of x will be equal to 0 when x plus root 3 is equal to 0. So when x plus root 3 is equal to 0 and x minus root 3 is equal to 0. Okay. So we will get x is equal to minus root 3 and x is equal to plus root 3. So when x is equal to root 3 and when x is equal to minus root 3, we will get the zeros of the given polynomial. So now we have to find the relationship. So sum of its zeros and product of the zeros. So what is the sum? Sum is nothing but root 3 plus minus root 3. So this both gets cancelled. So the answer will be 0. So this 0 divided by 1. So there is no coefficient of x. So it means 0x. So this is nothing but, you can either write minus coefficient of x divided by 1 is the coefficient of x square. So this is proved. Next, product of zeros. So root 3 into minus root 3. Okay. So root 3 into root 3 is 3. So minus 3. There is one negative sign. So minus 3 divided by 1. Okay. So minus 3 is the constant term. So constant term divided by 1 is nothing but coefficient of x square. So we verified the relationship between the zeros and coefficients. Okay, children, can you understand? Okay, let me go to the last example. Example 4. Find a quadratic polynomial. The sum and product of whose zeros are minus 3 and 2. So they gave the sum and zeros. That is, if we take alpha and beta are the zeros of the quadratic polynomial ax square plus bx plus c, then they gave alpha plus beta is equal to minus 3 and alpha beta is equal to 2. Okay. So here it is not alpha and beta. They give alpha plus beta. Okay. So that is alpha plus beta is equal to minus 3 and product, that is alpha beta. So we already know that alpha plus beta is nothing but it is minus coefficient of x. Coefficient of x is b. So minus b divided by coefficient of x square divided by a. Okay, this is nothing but minus 3 by 1. In the same way, 2 can be written as 2 divided by 1. So 2 is nothing but constant term. Okay, c. c divided by a. So we already proved this relationship. This sum of the zeros is equal to minus b by a and product of the zeros is equal to c by a. Okay. So here minus 3 divided by 1 is equal to minus b by a. So a is equal to, when comparing this equation, we get a is equal to 1 and b is equal to 3. So we get b is equal to 3 and c is equal to 2. Okay, so if we substitute the values of a, b, c here, we get the polynomial as p of x equal to a is equal to 1. So it is x square plus b is equal to 3. So 3x plus c is equal to 2. So this is the quadratic polynomial and the sum of the zeros is minus 3 and product of the zeros is 2. Okay, okay children, and you understand? Okay. So that's all for this session. Thank you for watching. So if you enjoy this video, just like, share and subscribe and hit the bell button so that you get the notification whenever I upload my videos. Thank you. Thank you for your support.